Hello everyone and welcome to the Math Bender. I'm Adnan Zaidi and in this section we'll discuss sketching related to logarithms. Before starting off with this, I would want, if you haven't seen the video related to exponential sketching and exponentials and logarithmic functions, the previous videos, I would want you to watch these ones before coming on to this one. Let's start. Alright, so up till now we have established that exponentials, when I say exponential, I mean e to the power x, 2 to the power x, 3 to the power x, anything to the power x. And logs, when I say log, I mean ln x, log 2 of x, log 3 of x, and so on. They are inverses of each other. And if I draw the exponential function, it will look like this. Where the y-intercept of this function is 0, 1, and the asymptote line where the graph does not touch is y equals to 0. This graph was e to the power of x, although you can also say 2 to the power of x, 3 to the power of x. Any exponential function may represent the same graph as long as it's just a sketch, because when it comes to sketching, all you need to keep in mind is the shape of the curve as well as the intercepts. So all of them will have the same intercepts and the same shape of the curve. But if you draw them on a graph paper, you will see small differences. So sketch doesn't matter. Those differences are irrelevant when it comes to sketching. Now if I have to draw the inverse, so f inverse of x is a reflection in the line y equals to x. So let me draw y equals to x. If this is the line y equals to x passing through 0, 0, and if this line is the mirror, the reflection may look like this. And the relationship of an inverse is such that x coordinate of the original function f of x becomes the y coordinate of the inverse and vice versa. So this point here is now 1, 0. The asymptote line, which was y equals to 0, is now x equals to 0 for the inverse function. So this is f inverse of x. Now since as I called f of x as e to the power x, any of these exponential functions, so you can call the same as ln x. This is ln x, lgx, log 2 of x. All of them will have the same shape and the same x-intercept. There won't be any y-intercept as the original function did not have its x-intercept. The domain of f of x was x belongs to real number and y was greater than 0. And same, the domain and range of f inverse of x switches. So as you could see, since y was greater than 0, the domain becomes x greater than 0 and y belongs to real number. Can you see it's just switching? When it comes to f and f inverse relationship, range becomes domain and domain becomes ranges. Alright, so let's see some of the examples of the parent function. So I'll take this example ln x, but mind you that If it is LGX or any logarithmic function, you can draw the same graph. So the graph will look like this. That's all you need to know. So this point here is 1 comma 0, and the this is the asymptote line, x equals to 0, or the y-axis. This is my parent function when it comes to logs. Parent function means the basic function where it all started off from. Everything else will be just an extension of it. The domain is x is greater than 0, and the range is y belongs to real number. If I say f of x minus 1, the same function becomes ln. Instead of x, I replace it with x minus 1, and the graph transitions to 1 unit right. So the whole system moves 1 unit right. So if this was the x and y axis, and I draw this function here, so as you could see that this point here was 1 comma 0, now moves 1 unit to the right and becomes 2 comma 0. The asymptote line, which was x is equals to 0, again moves 1 unit to the right and is now x is equals to 1. The domain now becomes x greater than 1, and range is y belongs to real number. If I say f of x plus 2, I can write this as ln x plus 2, and this means that the function is moving 2 units left. So the original function, which is our parent function, is now gonna move 2 units to the left. So the function which was like at 1 comma 0 had an x-intercept, moves 2 to the left, and is now intersecting at negative 1 comma 0. The asymptote line, which was originally at x is equals to 0, is now at x is equals to negative 2. And this function will have some y-intercept as well. Now, if you want to find that y-intercept, you can simply replace x as 0, and you will see that it is going to be 0 comma ln 2. Now the domain of this function is x is greater than negative 2, and the range is y belongs to real number. Now note that in all of these domains, this value represent this value represent this value, and we'll establish a few more facts related to this. Now, if I say f of 2x, the graph looks like ln 2x, which means the function shrinks on the x-axis, and the value initially which was 0, 1 of the parent function, as you could see, the original one, is now divided by 2 and gives you this value, which was 1, 0 is now half, 0. The asymptote line does not have any impact over it. It will be as same as x is equals to 0. So this here means that whichever number is here, so the x coordinate is divided by that number. So since x was equals to 0 here on the asymptote line, it doesn't matter there. Now the domain and range, you can say that x is greater than 0 and range is y belong to real number. Now this is a little bit different. 2x minus 3. Now this is a bit complicated in the sense that you need to understand that how to cater to 2x minus 3. The first step, you draw the function f of 2x, which is already there. The next step, if you take 2 common inside, you will see that x minus 3 over 2. Now 2x function, keep that in mind, the distance between the asymptote and the x-intercept is half. And this tells you the asymptote line is moving 3 over 2 to the right. So let's first draw 3 over 2. So this is the asymptote line at x is equals to 3 over 2 or 1.5. The graph will be half unit ahead of that, and this, which was initially at half, is after a transition of 1.5 will reach 2, 0. Okay, let's take another example. F of 6x minus 9. So this function, first step, you draw ln 6x. Now when you draw ln 6x, the value which was at 1, 0 is now going to be 1 over 6, 0. And the asymptote line is going to be x is equals to 0. Now for the next one, f of 6x minus 9 is going to be ln 6, if I take it common, x minus 9 over 6. You can also write 9 over 6 as 3 over 2. Now note that the difference between the asymptote and the when it is ln 6x is 1 over 6. And now this is the asymptote. It's moving 9 over 6 to the right. So you can write this as 9 over 6 or 3 over 2, 1.5. And 1 over 6 ahead of that. So plus gives you 5 over 3. So the next is going to be, this point here is going to be 5 over 3, 0. The domain is x greater than 3 over 2. The range is y belongs to real number. Now let's look at some more examples. If I say minus f of x, this means it is equals to negative ln x, and it means that it is a reflection in x-axis. The graph looks like this. So the point does not change, but the shape changes. Originally, you see the graph like this. The asymptote line is as same, so this is negative f of x. Let's see some of the practical examples here. Now for the first one, your step one is you can try going slow and do stepwise once you're confident about it, and then you can move directly in. So if you see ln x, that's your first step, so that you remember what a parent function is. It looks like this: 1 comma 0. The asymptote line is going to be x equals to 0. Your step 2 should be the same graph, just that since it is now ln 2x, this value, which was 1 here, is now divided by 2, makes it 1 over 2 comma 0. There's no change in the asymptote line. It's as same. Now the third part, and the most important one. Now step 3 is ln, take 2 common from this. Now if you take 2 common, it will be x plus 2. This tells you the asymptote. Now this tells you the asymptote, and since plus moving to the left, now if I draw this here, now the asymptote line is moving 2 to the left, so let me write that down here. X is equals to negative 2 because initially it was at x is equals to 0. As you can see that there is a difference of 0.5, half. So this value is also moving 2 to the left and will reach at negative 1.5 comma 0. The distance will remain as same. Why don't you just pause the video and try solving it? Step 1 is I'll draw straight away ln 3x. This point here is going to be 1 over 3 comma 0. The asymptote line is as same as x is equals to 0. The difference is 1 over 3. Step 2, take 3 common, x minus 2. This is the asymptote line. So minus 2 means moving 2 to the right. X is equals to 2, and the graph here, so 1 over 3 and moves 2 to the right, so you can just add the values. So this value here is 7 over 3 comma 0. Let's see some of the exam style question. Although the CAIs expect you to have the graph of ln x as an understanding of an inverse of exponential function. Nothing more than that. So all you need to understand that e to the power of x, and you need to know how to sketch the ln function in line with the inverse of an exponential function. So for this question, as we already aware of that log function, the parent function is greater than 0. The function lies on the right side of the y-axis. So by default it is x is greater than 0, the domain of this. So since this is what's making it move left or right, that does not matter. So all you need to remember is find out the position of the asymptote. So you can write this as x plus 3 over 2, and the asymptote is going, the curve is going to move to the left. So the asymptote as well. So the value of a is going to be negative 3 over 2. The domain is x is greater than negative 3 over 2. The range of the curve is pretty straightforward. So f belongs to real number. In order to find the f inverse, and this is the important part because this will help us sketch the log function. Now this is the equation. Ln 2x plus 3 plus ln 4 is f of x or y. So as you know that the first step what you could do is you apply the product law and you write 4 times 2x plus 3, as you're aware that Lg or ln A plus ln B is equals to Lg A times B. This is equals to y. So 4 times 2x plus 3 is equals to, taking the antilog, which makes it e to the power of y, and 2x plus 3 is equals to e to the power of y over 4. 2x is equals to e to the power of y over 4 minus 3, and x is equals to e to the power of y over 8 minus 3 over 2. You can also write this as f inverse of x is equals to e to the power of x over 8 minus 3 over 2. The domain of this function is the range of its original function, and the range of this function is going to be the domain of its original function. So the domain of the original function was this. So in this scenario, y is greater than negative 3 over 2. So in order to sketch both, since we are already familiar with the exponential functions and that's the way to approach it, so let's write that equation here and I'll sketch this function. So e to the power of x, I'll show you the transition by erasing the curve eventually. Now look at this. So this is e to the power of x. By default it is 0 comma 1. This point is 0 comma 1, e to the power of x. Now if I multiply it with 1 over 8, so this value will become e 0 comma 1 over 8. Now if I write negative 3 over 2, By default, the asymptote was I is equals to 0 or the x-axis. Now, moving 3/2 units down will give you, this is the asymptote, and the graph had 1/8 units difference. So 1/8 will go down and it will become -11/8. So the same curve will move down just a little bit steeper, and this point here is going to be 0,11/8 negative. If you want to find this, so instead of, if you replace it with 0, this is going to be now 3/2 is equals to e to the power of x over 8, and 24/2, which is equals to e to the power of x, and x is equals to ln 12. This point here is ln 12 comma 0. I'll erase the original function. This is all I need for the sketch. Now, this is f inverse. I've already drawn that, and the relationship of f of x and f inverse of x is the reflection in the line y equals to x. So just quickly drawing y equals to x, and the other function is going to be exactly a mirror. So this value, this switches, so it becomes 0 comma ln 12, and this value here is going to be -11/8 comma 0, and that is it. Until then, if you have any queries to ask, if you have, please do write in comments. If you feel like giving any feedback, that would be appreciated. Secondly, if you have any lecture recommendation you want me to cover, please do write that as well. I'll come up with some other video in my next session. Until then, take care. Bye.